Hello guys, I hope all of you are doing well. In this video, we are going to discuss our question, trapping rain water. So in the input, we are given number of non-negative integers that represent elevation, where the width of each bar is 1. And we are required to calculate that how much water it can trap after raining. Let's understand our question better. Okay, so this is our input array, right? Here as in the zeroth index, nothing is present, so that means it's zero value, right? And here it is one value again, nothing is present, so zero value. So what we are required to compute is total water trap, right? That's our task. Now what will happen? Rain will happen. So let's see. So rain will happen, and after rain water will get trapped. Let's see where water will get trapped. So here water will get trapped, and how much water will get trapped, as we are given in the input that this is one width, right? So here we can say 1 unit of water will get trapped. Now let's see here. Here also water will get trapped here, right? But it got a building both at the left and both at the right. So let's see for 2. Okay, so 2th index. So 2th index got a building at the right, as well as in the left. It's of 1 height and it's of 2 height. So this is for let me erase it. And its height is 0. So how much, we are talking about 2 index, right? So how much water is getting trapped here? First, let's not think about how much water is getting trapped. Let's talk about when water is trapping. Okay. Now let's see for 5, for 5 index. So here for 5 index, right? We got a building at the left, right? That is 1, as well as in the right we got a building 1, right? So here also we got a building that can hold your water. So here also that's why water is storing. Are you getting me what I'm trying to say? Let's see this example so you understand it better. Okay, so here we got 1 height, and in the left we got 2 height, and the right again we got 2 height, right? So if we got a greater height, right? If we got greater elevation in our left and right? So that means our water will get trapped. Are you getting me? So for 0th index, we discussed that there is no left elevation, so no water will get trapped. So I hope you understand when our water is trapping. Now, I want you to think about how much water is trapping, how much water is exactly trapping. Okay, so let's talk about 2th index. We can see the right maximum, right? Whatever is the minimum of right maximum and left maximum minus your height, that much water is trapping. So here its height is 0 and its left maximum is 1 height. So here 1, let's show me through red pen. So here 1 unit of water is getting trapped. Now let's talk about this. fourth index. Here, how much water is getting trapped? So as we can see, here its left max is 2, its right max is 3. So whatever is less, we know 2 max, minus your height. My height is already 1. So here what it indicates that you can store 2 units of water, but I already got 1 height. So can I write this formula? Can I write this formula? Max left and max right. Whatever is the minimum of max left and max right, right? Whatever is the minimum of max left and max right, that much amount of water you can store at your index. Perfect. So here, as we can see in the ninth index, so here it is equal, right? Your max left and max right. So that means you can here store 2 units of water. But we already got 1 height. So that we can only store 1 unit of water. So I have got a right minus my height, minus my own height. So that much unit of water I can store. Now that we know how much water we can store, right? Now let's talk about how we can solve this. Let's talk about the brute force approach. Okay, here I'm going to write brute force. Okay, so can we say, if we know the max left, right, and the max right, again we just discussed, if we know the max left and the max right, right, here if we know the max left and max right, and I calculate its minimum and minus my own height, so I will get my answer, right? And how will I calculate my max left? So if I am at a point, let's say I am at ninth index, so my I represent ninth index, so my I will traverse till 0, right, to calculate my max left, and same for max right, my I will traverse till the last till n minus 1, right? So this will give me my max left, this will give me my max right. So by this by this I can calculate that how much water will get trapped here simply by deducting my own height. Perfect. Now we know that this is not the most optimized solution. Why is that? Because this solution, it's going to take time complexity of O(n) square. Why? Because every time we traverse, we are going to traverse again to calculate max left of every element. And Now that I have calculated next data right, next data left. Now my task is to check. Now math dot minimum, right? Math dot minimum of what? Greater right minus next greater left. Here plus equal to. We have to calculate all the order, right? Math dot minimum next greater right next greater left minus my height, that is value. Now we also discussed we have to multiply it with our width, that is, what is our width? We have not calculated our width yet. Let's do it. It's simple. So int width is equal to in next greater right minus next greater left minus 1. Also here, and we have to extract the value, right? So height ngr next greater right to get the value height next greater left right minus my height into width. Perfect. So this is our code. Now I want you to see one condition. So here what we are going to do, check for everything, right? So now we are going to push 5, right? Going to push 5 and it's equal to 5. Now we are going to check. Now we are going to check if, yeah, so for 5 value, right? Sorry. So we got 5 value and we know that 5 is greater. So we know 5 is our next greater right. Again, 5 is our next greater right for which value? For 4 value. So I'm going to pop this. Pop my 4 value. Now, I know that here no next greater left exists. Right, for 4 value, no next greater left exists. So what I'm going to do, if that's the case, then I'm going to simply break, because I know that my water can't get trapped if it got no next greater left, no building at the left that is greater. So here I got to write a condition. If stack dot size is equal to 0, then simply break the loop. Now let's try running our code and see if this works or not. Also I've not returned it, I think. So let's return it. Also if there's some error. Yeah. Return water. Right here. I have already used value variable here. Let it be current. Right. Also height st.pop, because it is going to store the height. You have to extract the value and minus current into width. Now let's try running it. Return water. Okay, small mistake. Wrong answer. Let's see why wrong answer. Okay, we have not pushed the element. Of course, we have to push the element. So here st.push I, and now run it. Wrong answer. A very small mistake here. We forgot to add brackets. Of course, we need to add brackets, and then after we get the solution, we have to multiply it with our width. Should work now. Let's try running it. Perfect. Finally accepted. I know there were a lot of mistakes, but some mistake happens. It's fine. Perfect. I hope you have understood the code. If you liked this video, thanks for watching.